What's up, math fans? Today we are going to solve fractional equations, and this is an Algebra 2 topic, but actually in Algebra 1 you already get introduced to how to do this, so I would call this a prerequisite. It's called Professor Noy's Solving Equations with Fractions. The only difference is here I specifically only solve equations where there are integers in the denominator. Here there's not only integers, but there's also variables. So my fractional equations here have variables. In this initial video, no variables. It's a little more simple, but the steps are all the same. So it's a little bit of a new topic. And I think that you learn best if you watch one video at a time throughout the semester. I'm curious if people actually do like their favorite show and just binge watch Professor Noy videos. I wonder if that actually helps. So I'm trying to get more people to watch, especially in my own classes, so that you'll do better on tests. So if I could get even just one class to hand in all the information on all the videos that I've done this year, I will shave this beard. Alright, but you're more interested in how to do this math. So let's move on. I have here what's considered a fractional equation. There's an equal sign, there's fractions everywhere. There could be 3, there could only be 2. 2 is a lot easier. 2 I actually prefer to cross multiply, so I specifically designed these with 3 fractions. You don't even need denominators in all of them. You might just have 2 fractions and 1 whole number. Hopefully you know if you see a whole number, like 7, you can just put that whole number over 1, and now it's a fractional, it's a fraction. Also, you might hear me say least common multiple or least common denominator. It's not that they mean the same thing, but I mean the same thing when I say them. For example, here I need a least common denominator, so when I look for that least common denominator, I'm looking for the least common multiple of the denominators. So I'm looking at the 6x, the 5x, and the 30, and it might help you to even look at it like this and figure out what do they all go into. And there's another style, I'm not going to teach it this way, there's another style where they tell you create a common denominator and then just add the top like you did in 3rd grade. I'm not going to do it that way actually, I'm not going to try to create a common denominator. I'm going to find that common denominator and then multiply by that common denominator. You'll see what I mean. So let me see. First of all, I'm going to ignore the variables. It's confusing me. I'm going to pretend it's not there. So if I count by 6s, let's see if I get this right. Right? I could keep going, but I know where I'm going with this. If I count by 5s, 10, 15, 20, 25, 30, right? And then I count by 30s, I'm already there. I have what's common, 30. So that's how you find your common denominator or your common multiple of different denominators. All right? So step 1 is to find a common denominator, and that common denominator can't just be 30 because there's an x here and here. It has to be something that you can make them all look like. So my LCD or my LCM will be 30x. And then step 2, now that I figured it out, is I'm going to multiply every term by 30x. And you're allowed to do that because in an equation, as long as you do something to the left side, you must also do it to the right side to keep the balance. So you're allowed to, in algebra, multiply by whatever you want, as long as you do it to every single term. So I'm going to take my 30x and multiply here, here, and here, all 3 terms. And again, if you were learning in a different style, they might tell you just multiply by 5, and it creates a 30x. I don't want to create a 30x, I actually want to cancel out the denominators. I want to get rid of them right away. So by multiplying by 30x, I can now cross cancel. And if you saw this video, you'll understand what I mean. Cross canceling is basically a fancy word for divide. X divided by x, they cancel each other out. They leaves you with 1. So I'm going to cross out the x's. 6 goes into 30, right? 30 divided by 6 is 5. So those cancel out, and I replace the 30 with a 5. Now, again, my x's cross cancel. Goodbye. It's hard to see that, so I'll go this way. 5 goes into 30 6 times, and here the 30s. Goodbye, and it just leaves me with x. So step 1 was to find the least common denominator. Step 2 is to multiply by the least common denominator. Step 3 is to cross cancel that least common denominator. Guess what step 4 is? Just put everything together, whatever's left. So I got 5 times 2 plus x. I'll write that for you. equals 6 times 3, and then plus, what's here? A 1 and an x. Be careful. Look very carefully. It's like you're hunting. Don't people want to rush and just put quickly what they see and they forget stuff. 1 times x. All right? So this is going to, well, I'm going to distribute here, right? I was implying that earlier. So that's going to give me 10 plus 5x equals 18 plus x. And now this is a basic algebra 1 problem. Let me bring my x's to the left side and my whole numbers to the right side by doing my additive inverse. So these x's will cancel and these 10s will cancel. And now I've got variables on one side and whole numbers on the other side. So this is 4x equals 8, divide by 4, and x equals 2. And there's my final answer. You will now go back and check to make sure this is an acceptable answer, because sometimes it doesn't always work out. So I'm going to go back to the beginning, plug in a 2 here, and see if it works. So 2 plus 2 over 6 times 2, 4 over 12. Does that equal 3 over 5 times 2? 3 over 10 plus 1 over 30. So, oh no, fractions, I'm scared. You can type that stuff in the calculator, turn it into decimals, and see if the left side equals the right side. Okay? So, hopefully, it'll work, but check. Now, I wrote something else. I wrote stipulation undefined. Also, I've explained what undefined means. So there's a stipulation. When they give you fractions, they have to tell you a secret. They say, by the way, this can't be undefined. The bottom can't be equal to 0. There's no way 30 could equal 0. But it is possible for 5x to equal 0. 5x could equal 0 if x itself was 0. So they will give you a stipulation, and it doesn't affect the solution at all. It doesn't change anything. But they should tell you in the problem, by the way, x is not equal to 0. Because if it was, that will make the whole bottom 0, and then it's impossible to do. So if you get something like x equals 2, it should probably work. If you got 0, wrong. Okay? Let's go here. Notice p cannot equal 5, because that would make this 0. P also cannot equal -3, because that would make this 0. Alright, so let's see. Step 1, what did I say? Find the least common denominator, also known as the least common multiple of the denominators. So now it's funny because I have 3 different denominators. So remember when I was over here and I had the 6, the 5, and the 30? There's a shortcut, an easy way to do that. What I did was I listed it out and counted it out. You could do it in your head, you could use a calculator. The basic way to do it is just take the 6 and the 5 and put them together. The 6 times 5 is 30. Is that a coincidence? Yes and no. Because it's not always those two numbers multiplied. Sometimes it's a smaller number than that. But in this case, I'm looking at a 5 and I'm looking at a 3. So I'm going to do 5 times 3 is 15. But what about the p? So then you're going to try to fit the p in somewhere. Let me tell you, when this is one denominator and this is a different denominator, there is no way to make this look like this or this look like that. It's impossible. So my least common denominator would just be this whole binomial times this whole binomial. P minus 5 times p plus 3. This entire thing is the least common denominator. I can make this look like this. I just multiply. I can make this look like this. I just multiply. So in cases like this, it's easiest to just smoosh them together. Alright, so that's what I'm going to do. Step 1, find the least common denominator. Now what was step 2? Multiply everywhere. So I'm going to put my, what did I say, p minus 5 times p plus 3 here. I'm going to put it here, p minus 5 times p plus 3. And I'm going to put it, I hope you can see this, p minus 5 times p plus 3 over there, all right? And if you can't see it, just rewind it because I said it so you'll hear me. So what happens, p minus 5 and p minus 5 is no coincidence that they cross cancel right away. That was the whole point. Goodbye, denominator. So what's left? 3p times p plus 3. These two things, terms. Now here, p plus 3 is on the bottom, p plus 3 is on top. Goodbye. And I have a minus sign, so I'm going to put minus 2 times p minus 5. Okay? Sometimes people forget that minus sign. It's part of the numerator. So minus 2 times p minus 5. Equal sign, guess what? Goodbye. P plus 3's cross cancel, and I'm left with p times p minus 5. Now the rest, I can't teach you fresh. This is just comes from practice and understanding algebra. You see parentheses, let's multiply, we're gonna multiply, or distribute. So this is gonna give me 3p squared plus 9p, that's a 9, right? Minus 2p, negative 2 times negative 5 is plus 10 equals p squared minus 5p. Now I want to collect my like terms. I say the word collect because some of them are on the same side, you combine them, but if they're on different sides, you bring the inverse and you bring it to one side. So I am going to subtract p squared and add 5p. Subtract p squared and add 5p. So try to stay with me because I'm going to skip a step. This is going to give me 2p squared. Follow me? This is 9p plus 5p is 14p. But there's another like term right there. 14p minus 2p is positive 12p. And then the plus 10 is going to drop down. And that equals, nothing's left on this side equals 0. Doesn't that look familiar? That's a quadratic. And it's in standard form because it equals to 0. If you didn't know that, go look for my video on solving quadratic equations. What do? There's a coefficient. I taught you something called rainbow. But before you even do rainbow, GCF, take out that 2. Because 2 goes into all three terms. Now I'm left with p squared plus 6p plus 5. Do you know what to do now? Couple things. You can drop the 2 down and continue. You could right away divide both sides by 2, and 0 divided by 2 will be 0. So the 2 is no longer significant. Now I need to factor this using the sum product method. That's going to be p plus, I need two numbers, multiply to 5 and add to 6. That's plus 1 and p plus 5. 5 times 1 is 5, 5 plus 1 is 6. Alright, you can drop the 2 if you want. Equals 0. And then I taught you something called the t-chart. If this times this equals 0, either this is 0 or that's 0. When you plug in the t-chart, p plus 1 equals 0, which means p has to be negative 1. Or p plus 5 equals 0, which means p has to be negative 5. These are my two answers. Either p is negative 1 or p is negative 5. I'm still not sure, so I'm going to go back to the beginning. Plug in negative 1 here for everywhere you see p and see if that works. See if this side is equal to that side. If it works, great, you got one answer. Then you do the same thing with negative 5. Plug in negative 5 here, 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 and here, and see if that works. Again, if you're scared of fractions, you can just type in the calculator and turn them into decimals and see if that works, and it should. So you get two solutions. And my stipulation that I said in the beginning was, as long as p is not equal to 5, because that would make this 0, can't have a 0 down there, and as long as p is not equal to negative 3, you should be good. So I'm happy. Any questions, type them in the comments and I'll get right back to you. Thanks for watching. See ya.